Today's port channel and vPC. Port channel and vPC. Why I'm putting these two topics together? Because they are both connected. They are interconnected. Port channel or ether channel, or sometimes you call this port aggregation, bundle, link bundling, or port mirroring. Various terms, we use port channel. We also have fiber port channel. We do bundling of multiple fiber links, and that is fiber port channel. In Nexus, it supports fiber port channel. Nexus supports fiber port channel. MDS switches, Cisco MDS switches, multi-directory switches, they do support fiber port channel. This is Ethernet port channel. Both the port channels, vPC and port channel, both are fiber. Both are Ethernet. We are not talking about fiber port channel here. Ethernet port channel, Ethernet technology. First, we will understand port channel, which we learned in various courses like CCNP, CCNA, port channel with LACP, PAGP. We'll try to understand it one more time, and then we'll get into understanding of vPC. What is a port channel? It is aggregation of links. We take multiple physical link and combine it as a single logical link. As a result, we increase bandwidth. We also provide redundancy. If one of the member of the port channel goes down, you still have the reachability to the other device, the other end, without any downtime. So we have redundancy because you got multiple links in the bundle. If one of the link goes down, the bundle never goes down. Till that last link goes down, the bundle will be up. As I said, multiple physical links now appear as one single logical link. Advantage, increased bandwidth. If each link is 100 meg, you get 300 meg. If one link goes down in the bundle, the conversation that is happening, the session that is there, the communication that is going on, they don't get interrupted. Only the bandwidth get reduced to 200. From 300, it gets reduced to 200. So you got a redundancy, you got increased bandwidth by doing port channeling. Now, between what all devices we do port channel? We can do port channel between a Cisco switch and a server. We can do port channeling between a Cisco switch and another Cisco switch, or another vendor switch also, doesn't matter. We can also do bundling between a layer 3 multi-layer switches, which acts as a router, and a switch. You can also do bundling between a router like ASR and a layer 3 switch or a normal switch. So port channel is between switches, between switch and a router, between switch and a server. If the servers don't support LACP, then we have on mode. Yeah, so we have options, we have different combinations. Port channel can be between switch and a server. It's not only between switches. The benefits, which we just saw in the previous page, we got redundancy as a benefit. We got increased bandwidth as a benefit. We load share and send across multiple links. If no port channel, what is the problem? If no port channel, then you cannot load share across multiple links. Why? Spanning tree is going to block in order to prevent loop. When you don't bundle multiple physical links as a logical link, spanning tree will block. You can't have redundant active links. In order to prevent loops, spanning tree is going to block and give you only one active link. So we will be subjected to spanning tree limitations. Port channels are seen as single switch port by the spanning tree protocol. As a result, there is no block. Single switch port. Why there is a block? Even though physically there are multiple ports, when you enable port channels, spanning tree will see those multiple physical links that are made as a single logical link as a single switch port. So no blocking. Is there any question out of what we have spoken, what we have heard so far? Hmm? Yes, yes. So the question is this: whenever you have more than one port channel between switches like this, let me draw it for you. We have a switch with multiple bundles, not just one bundle. So these three links or one bundle, there will not be any block. All three will be active. And now you got another, let's say two links. This is another bundle. So spanning tree is going to block one of this, and this only will be active bundle. This bundle will be a standby bundle for the same VLANs. If it is different VLAN, both will be active. For example, if you allow here VLAN 10, 20, 30, in here you don't allow 10, 20, 30, you allow 40, 50, and 60. Then this bundle will be active for this 40, 50, 60 will be active here. Both bundles will be active here. You can do that manual load sharing if you want. You can also set priority and make failover to happen between these bundles for these VLANs. So what I'm trying to say here is this is seen as one port. This bundle is seen as one port. This is seen as another port. So spanning tree will definitely work. It will block. Only when it is seen as a single port, spanning tree cannot do blocking. So the port channel, you're welcome. The port channel use case. We aggregate link between the switches to increase the bandwidth and redundancy. Connecting servers with multiple network interface is also possible. So servers can now send more amount of data. Yeah, we have big servers with V switches inside with various VLANs, and you may have a trunk configured on the V switch inside the server. So all VMs will be sending huge amount of traffic at the same time. So you definitely need some more bandwidth for that. We have port mirroring, not port mirroring, port bundling. Port bundling, not port mirroring is PAN. I'm sorry if I used port mirroring. No, this is not port mirroring. Port bundling, aggregation of links. Earlier I said port mirroring. That's wrong. It's not port mirroring. That's the wrong term I used. It's port bundling. All right. So that is vPC. Sorry, that is port channel. We have seen what port channel is and the protocols involved in negotiating port channel are LACP and PAGP. Next, we are going to see vPC, where PAGP is not a solution. PAGP will not be a negotiation protocol. You have only LACP as an option. LACP. You can't use PAGP. Now let's go vPC. Why do we need vPC in first place? When we have only a simple port channel, your bundle is only between two switch, back to back, the same switch. All the links in the bundle belong to the same switch. Whereas vPC allows to create a single port channel that spans across multiple switches. This multiple switch will be presented itself as a single logical entity. That's what vPC does. vPC allows you to have links coming from different switch, and these different switches will be seen as one single logical switch. Here it is one physical switch. Here it is single logical switch like this. vPC allows bundling these two links, whereas simple port channel will allow only bundle between the same switch. These two links belong to same switch, whereas this two links belong to multiple switch. See, vPC allows for creating a single port channel. This is single port channel number 10. This is also port channel number 10. Here, single port channel number 10, but it is spanning across two or more switches. Right now, now we have three switches. Here it is only two switches. Can we have more than three? No, vPC don't support more than three. Here, though it says more switches, I don't believe. You can have only, if you want to have four switches, this is allowed. You see, like this, you have one bundle, and now you can have another bundle like this. This is another bundle. And if you want another switch here, there's another bundle. This is okay. But if you see any, this is one vPC, only three switch involved. This is another vPC, another three switch involved. This red one is another vPC. This is another, only three switches involved. Do you have any question on what we learned from this speech? Yes, you can have server. You see, I can have two device, but the down device is a server. vPC is, this is vPC domain. Yes. Next question. Can a server come into picture? That was your question, and I answered that question. Yes. Next question. Even if it is on mode, it is okay. It can be a LACP supporting server, or even if it don't, no problem, we can have even on mode. vPC member ports can be on mode. We'll talk about the member ports in some time. So, any other question? What is vPC? vPC, which is also known as multi-chassis ether channel. By this time, you know what is the meaning of multi-chassis ether channel. Earlier, we saw in the previous page, it is single switch, whereas vPC is multiple switches, multi-chassis. That's why multi-chassis ether channel or multi-chassis port channel, MEC. It is the feature of Cisco and not supported in all Cisco device, only on Nexus. That's another limitation of vPC. This is one of the limitation of vPC. You see, to have vPC, you should have only Cisco device. But the down device can be a non-Cisco device or a server. The two devices that you aggregate, the two devices that you combine as a single logical switch need to be a Cisco Nexus only. I repeat. You can have this as a non-Cisco switch or a server or a server. But this two that you're going to have on the top needs to be Cisco Nexus only. Right, so Cisco Nexus switch that provides the ability to configure port channel across multiple chassis. This is what we call it as vPC peers. These two join together and appear as one logical switch. These two that participates in this feature, we call the switch, these two switch as vPC peers. vPC peers. Now, if you are from Cisco background, then you know VSS also. Not only on Cisco, even other vendors support VSS. Sometimes there may be a slight change in the name, but VSS is again same like VPC. But the difference here is VSS will have only single control plane. So you have single control plane for management and configuration. Whereas VPC, each peer can be managed and configured independently. VPC, both the switches are managed independently. Whereas VSS, which is supported in Cisco Catalyst 6500 series, they create a single logical switch, same like VPC, but the difference is even the management and configuration is only through a single control plane. Whereas here, the management and configuration is via separate control plane. It means each peer have their own control plane. In VPC, they have their own control plane. In VSS, the two switches that you combine will form single control plane. Single logical switch, single control plane. Here, single logical switch, but different management plane, different control plane. They both can be configured independently. That's the different comparison between VSS, virtual switch system, and VPC. Yeah, do you have any question? See, the control plane, once they form one logical switch, only the active member, one switch is what you will be logging in. May the switch A or switch B, whichever is primary. Only on that switch you can put configuration related to VSS. Whereas on VPC, you can do it on both switch A and switch B. Switch A may be the primary, but when you put configuration on switch B, it will go to primary switch A automatically. Though they, mm, it will allow only to configure on via one switch in VSS. In VPC, you can configure via both the switches. Now, the key features: multi-switch port channel, loop-free topology, increased redundancy and low rebalancing across multiple paths, consistency. All right. So these are all the advantages, key features. You know what is multi-switch port channel already, presenting more than one switch as a single logical entity. Usually when you do that, there will be loop, but here it is loop free because those upstream two switches are not seen by spanning tree as two separate switches. They are seen as one logical switch. Next is increased redundancy and load balancing. Earlier, we used to have load balancing between links that connects to the same switch. Now two different switches. So you have optimum utilization of all your resource here. So better load balancing because you are going to use multiple paths that are in different devices. So you can now utilize all switches. But when there is no VPC, because of block, you will not be able to use some switches. Say, for example, when you don't have VPC, there's going to be a block here. So you will not be able to use this bandwidth. Not only that, this resource, this switch itself, all traffic will go this way. Whereas through VPC, you are utilizing this CPU, this bandwidth, multiple paths between devices. So increased redundancy and load balancing. Consistency ensures that both the switch and VPC peer has the same configuration. Yes, we have a link called peer link. That peer link in VPC will help to get synchronized between themselves. So they will have saying similar configuration, sessions, etc. Even the MAC address table, everything gets synchronized. So this avoids inconsistent MAC address table or STP topology change issues. Any question on what we have learned here? Right, where do we use vPC? Wherever you have Nexus switches, connecting pair of Nexus switch to a server or other devices, maybe another switch, another catalyst switch, or a router, where you don't want loop, but you want to use all the available resources, then you need vPC. Next, wherever you want, yes, please. Yes, The down switch can be a catalyst switch, or it can be a normal um, switch of any vendor, or it can be a server of any vendor. But only the two switches that you form as one vPC domain, that should be Nexus. So the other use case is whenever you want a high resilience, meaning you want to expand in the bandwidth, the efficiency, wherever you want high bandwidth between the switches and devices in the data center, we use this vPC. So now, what are the key differences between vPC and port channel? 3 points. All right, the first one is the scope of use. Where do we use vPC? It's only possible in Cisco's data center, where you have Cisco switches, wherever you run Nexus operating system on the device. Not possible on normal catalyst switches or any other vendor environment. Whereas port channel is generic. Then the topology support, as we said earlier, spans across multiple switches, vPC, whereas port channel is only between two switches. And then when you talk about redundancy and load balancing, both does redundancy and load balancing, but the difference is, as we already know, in vPC, it's a single physical switch, whereas, sorry, on normal port channel, it is single physical switch, whereas in vPC, single logical unit, multiple switches, physical switches, multiple physical switches, which are presented as single logical switch. And the redundancy is between this multiple physical switches on the top, which is considered as a single logical unit. So both the technologies provides aggregation, redundancy, load balancing. vPC is possible only when we have Cisco Nexus switch. Any questions so far? In data center, whenever you have a server or a classical switch connected to two upstream switches like Nexus 5000 or Nexus 7000 or Nexus 9000. So this may be a server or a switch. And when you're trying to connect to Nexus upstream in the data center, usually spanning tree will come and block this port. But when you make it as a port vPC, there won't be a block. This is how vPC is used in data center. You got it? That doesn't matter. That doesn't matter. This is a layer 2 concept. vPC is a layer 2. If you have ISP, then your packet will be routed if the destination is Yahoo. If the destination is local, then it will be local switched. Right? Now, let's get into deep dive of vPC, understanding Cisco virtual port channel. Right, as we already saw, it is going to provide you a single logical switch so that you can do load balancing across the switches without any blocking. No STP limitations here. We have redundancy. So avoids STP blocking. That point. Because of vPC, you don't have STP blocking. Now, these are the components that vPC feature got. VPC peer switches. You know what is VPC peer switches? Those two switches on the top where we configure VPC. See, we don't do any additional configuration on the down switch. The down switch will do normal port channel link configuration. See here, we have one switch. This switch has got no idea that you have done VPC on the top. In this switch, you do normal port channeling. Normal port channeling with LACP or on mode. Don't use PAGP. Normal port channel. Only these two switches, we have VPC configuration. And the configuration will be almost similar. We'll talk about the configuration sometime later. Now, peer switches are these two switches that are going to be combined as single logical switch. VPC peers. Pair of switches that are combined. Peer link is a link that is connected between, and this link need to be a high-speed link. Why? Because these two boxes now appear as one logical box, which means whatever is learned here need to be quickly learned here, quickly synchronized. The control plane traffic and the other informations need to get synchronized very fast. All that this switch knows, I'll call this a switch 1, should be known by switch 2 and vice versa. For that, you need a link for synchronization, and that link, if it is small bandwidth, slow link, problem. VPC cannot work effectively. So for fast synchronization of this control plane traffic between these two peer switches, we need a high speed link. How do you achieve high speed? Take 2 or more link and bundle. Normal port channel. In order to support this VPC, you do what? A peer link bundle. That's recommended. Is this bundle a port channel? No, it's not port. Sorry, it is a normal port channel. It is not VPC. For VPC to work, fine. For VPC to work in an expected manner, you need a fast synchronization. So for that, what you do, you take 1 or more, 2 or more link and bundle it. And the peer link need to be a high-speed link. For that, I'm going to use bundle. I'm going to use port channel. Is this 2 points clear for you? Yes, that we'll discuss later. Now, the member link. What is a member link? See, the link that is going down to the server or another switch. This particular link is what we call it as member link. The link that connects the device to the VPC peer. The link that connects the device, which device? The down device to the VPC peer. Which is VPC peer? This one. This link appears as a single port channel to the connected device. According to this device down here, this is a single port channel, even though it is coming from 2 different switches. Next, there is another link that we are going to use called keep alive link. Keep alive link is a link which we connect between these two, and mostly it will be a management port. Management port. That's what most of the time we use. You may use any port, but usually we give management port, which is already a layer 3 port. What is the purpose of this keep alive link? We know what is the purpose of peer link. The purpose of peer link is for synchronization between the switches, peer switches. And this is a layer 2. It's a layer 2 link. Peer link is a layer 2 bundle, high speed link. Keep alive link is a layer 3, means you will have an IP address here. Let's say, for example, 172.16.0.1, whereas here you will have 172.16.0.2. Yeah. Then what is the other difference? Why do we need to have this keep alive link? I already have a peer link for synchronization. Then why am I having this keep alive link? See, this is a kind of second opinion. What if this peer link goes down and both the switches are available? If there is no keep alive link, then I will not know whether the other switch is available or not. But when I have a keep alive link, I am getting the heartbeat. What beat? Heartbeat. I know that the other switch is still alive because this peer link, though peer link is dead, the keep alive is responding. These two switches, they send a ping message between the peer switches to detect failure. That's why they call it as health monitoring, heartbeat. If the heartbeat is good, the health is good. But this link is not going to be used for synchronization. It is only for connectivity check between these two peer link. It is just for health monitoring. It is just to detect the failure between these two switches. If one of the switch goes down, both peer link and the keep alive link should fail, correct? If one of the switch goes down, both peer link and the keep alive link should go down. That confirms that the other partner is dead. But if any one of this is alive, then it will continue providing the vPC service. The vPC will not break if any one of this is available. That's why it is written a separate out-of-band link used for health monitoring. This health monitoring is also done by peer link, meaning they are connected, they're getting synchronized, all the stuff. But this is layer 3, that is layer 2. vPC is layer 2. Keep alive is layer 3, that's why it is out of band. It is separate, but contributes to vPC. How it contributes? By detecting the failure between the peer links, the peer switches. By detecting the failure between the vPC peer switches. You see this picture. You have peer switches, two switches on top. In between, you have a bundle. You see, they have put a bundle. Why? Because the peer link need to be a high-speed link. The keep alive link is simply a layer 3 link. You don't need to have a bundle. For keep alive, there is no need for a bundle. It is simply a layer 3 heartbeat to detect the failure. Whereas the peer link is for synchronization as well as for the connectivity. So that needs to have more bandwidth. That's why you have a bundle. Let's say this is port channel 100. This is a member port, port channel 100. This is another port channel 10. And what is member port? The port that is connecting to the downswitch, or the link, the port that connects to the vPC peer from the downstream to upstream is the member port. All this together forms vPC domain. This is what one vPC domain. Is there any question so far? What we have understood? Do you have any question? Hmm? Hmm? You can have more also. Why not? And I recommended is this. For example, if you are having one more here, try to have another one here also. Because when they load share, if bandwidths are equal, then it will be properly utilized. You understand? 10 gig, 10 gig, 10 gig, 10 gig. So left hand side 20 gig, right hand side also 20 gig. If I have 3 link here, then it will be 30 and 20. It won't be nice. So better if you have one link to one peer switch on the top, have only one link on the right also. If you have two link on the left, then you have two link on the right also. You can have any number. How many number? Maximum is 16. You can have up to 16 here. So 8 here, 8 here. Right. So now you know. Now it's the same thing. A few points are repeated here. You see what is VPC peer switch. You know, member port. You know, keep alive. You know, peer link. You know, but I added something more in this page. This is simply an introductory level of peer link, member link, keep alive link, peer switch. I have added something more here. Let's see what is it. You know what is VPC domain? Oh, sorry. VPC domain, it includes VPC peers, keep alive links, the member ports, which is port channel. As I said, the whole diagram here is VPC domain. VPC peer switch, the other switch within the VPC domain, each switch is connected via a peer link. That is what VPC peer switch. If you have the two switches that are connected via VPC peer link, that is what forms one group. It is also worth noticing that one device of the peer among the peer, it will be primary and the other device will be secondary. Please listen this. You have two peer switches here. Among these two, one will be primary. Primary will be taking the role of learning MAC address, synchronizing the MAC address table with the other switch. You know, so the primary switch will respond to the ARP, etc. MAC address learning, etc. So if both learn, then there will be duplication. Forwarding is done by both, but learning cannot be done by both. So there is one primary and one secondary. If the primary fails, the other one will become the primary. We call it as VPC role, a peer role. While configuring also, I'll show you what do I mean by this. VPC peer role. So among these two switch, one is going to be the primary. Which one? You can configure. By default, the role priority will be 100. The switch with the lower priority will become the primary. So one of you did not mute your mic. Please mute. I am hearing noise. Thanks. The switch with the small priority becomes the primary. Right? So we have two switches. One will be selected as primary, the other will be secondary. We'll talk more about this in coming slides. Member port included in this vPC. Keep alive link. Keep alive link is a layer 3 link that connects both the peer switches, and it is only for heartbeat monitoring traffic to and from the peer switches. Monitoring is performed to ensure that both the switches are operational and running vPC. What is vPC peer link? The link that connects both the peer switches. I told you it is a layer 2 link, high speed link. Because it's layer 2, it carries what? BPDU. If you have HSRP, hellos, MAC addresses. In the event of vPC member port failure, it also carries unicast traffic to the peer switches. If any member port fails, then the traffic will fall on the other active link, which is on the other switch. So all these informations are shared via the peer link. What is an orphan port? This is not in this picture. Orphan port is not in this picture. Let me draw here for you. Let's say you have a server here. And the server is not a member of vPC. See, vPC member, these two only vPC member. But the server wants to talk from A to B. So B is a member of vPC, which is communicating to A that is not a member of vPC. We call it as orphan port. The ports that are not the member of vPC, but is communicating to the member. Such port or orphan port. Let's see what this line paragraph says. An orphan port is a port that is configured with a vPC VLAN. Yeah, they are in the same VLAN, but they are not inside the member. They are not inside as a member. They are not configured as a member, but this member and that port are in same VLAN. This is in VLAN 10. This is also in VLAN 10. So all the members of the VLAN in which the member port is, they're all called as orphan port. Let's say VLAN 10 has got 5 ports. One of the port is a member of the vPC, but the other 4 is not. How do you call the other 4? Orphan port. Other 4 port of same VLAN 10 is orphan port. Any question in this page or what you learned so far? No, definitely not. So I have explained enough about orphan port, peer link, right? Here they have two VPCs. One is VPC 20, another one is VPC 40. Sorry, one is vPC 30 and 40. 30 is having these two, 40 is having this two. So this is one vPC, one triangle. This is another vPC. 3 device in vPC. And we have a peer link, layer 2, bundle, fast link, which carries BPDU, MAC address, etc. Keep alive link for checking connectivity, availability of two peer, and also to identify the failure. Now, how vPC works? We are going to see the configuration, the synchronization, the load balancing, and redundancy.